Hey guys, welcome back. Today's lesson, welcome to probability or take a chance on me. Those creepy people right there. You know this song? Chance, 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 chance. Anyway, I'm sure you know the song, but that's ABBA. They look pretty tan to me. Make sure you're taking notes on the handout. Fill it out as we're going along. It's very easy. Take a chance on me. Probability, what are my chances? Are you ready? Me too. Let's hit it. All right. On the front, probability. Probability is a number between 1 and 2, or between 0 and 1 that measures the likelihood or the chance. This is where you're filling it in. That an event will occur. So the chance that something will happen. When they say event will occur, that just means the chance that something will happen. The blank, the outcome is the possible result. Right? The possible result of what could happen. It doesn't mean it always happens. It means it's the chance or the possibility that it could happen. What's an event? An outcome or a collection of outcomes. That's a fancy math word for just recording the data. Right? So if I'm rolling a dice, every time I roll it, that is an outcome. And the sample space is basically just the set. In other words, all your data of all possible outcomes. Hopefully you're filling this out. So basically, the probability is a chance something will happen, and every time I perform the experiment, I get a result, right? I collect the data. So you're going to see a capital letter P like this all the time, and then something in parentheses. And basically that means the probability of an event, or I could say the number of outcomes or possible results, right? We know that word means possible result. It's the number of possible outcomes over possible number of outcomes that you get, and then over the possible number. Once we get through this vocabulary, it'll make a little more sense when we go through a few examples. We said probabilities are expressed between a number between 0 and 1. The closer the probability is to 1, the more likely the event will happen, and the sum of all possible outcomes is 1. So if I add up all the chances or all the different outcomes that are possible, it will equal 1. And think about a percent. When we have percents, right, we'll have like 75%. See how that's less than 1? 90%. Remember, to make a percent into a decimal, we move it twice. So 0.90 equals 90%, right? So the closer we get to 1. 0.99 would be 99%. Good, I'm glad you're getting it. All right, describing possibilities. It can be written as a fraction. We all know what fractions are. We love them, right? Yes, we do. It can be written as a decimal. And I know you know the last one. It can also be written as a percent. And describing possibilities. This is something you've been doing for a long time. If it has a 0 chance, it's what? It's impossible. Right? 0 chance, impossible. 1/4 chance, a 25% chance, right? If I took a calculator, divided 1 divided by 4, I would get 25%. But that is unlikely. A half is equally likely. I know you're copying this down. Because I have an equal chance of not getting or getting it, right? 50% chance. 3/4 of a chance, or 75%, would be likely. And 100% chance is certain. Right? The chances of having math homework is almost certain. All right. Determine the likelihood or probability. So we've got a fair number cube. We call that a dice, right? There's 6 sides in a dice. My chances of rolling 2, well, only one of the numbers is a 2, right? So 1 out of 6. What are my chances of rolling an odd number? Well, odd numbers I could roll are 1, 3, and 5. So my chances of rolling an odd number is 3 out of 6. Or I could say a half. My chances of rolling at least a 5, that means a 5 or a 6, right? At least a 5. Well, there's 2 numbers that I could roll that would be at least a 5. What's an integer? My chances of rolling an integer? 100%. Certain. I got to roll something. And the probability of rolling less than 3, not 3 or less, just less than 3. There's only 2 numbers less than 3. So it's 2 out of 6. And what are my chances of rolling a negative number? 0. There's no negative numbers on there. So my chance of rolling a negative number is 0 out of 6. Let's do a couple problems. There's 3 choices of soda: Coke, Sprite, and Dr. Pepper. The probability of getting a Coke is 3/10. The probability of getting a Sprite is 1/5. We're going to change that to 2/10, right? So we can add that together real quick. They want to know the probability of getting a Dr. Pepper. Well, if the probability of getting a Coke is 3/10, and the probability of getting a Sprite is 2/10, we add those together and get what? You guessed it, 5/10. So if my chance of getting a Coke or a Sprite is 5/10, what's my chance of getting a Dr. Pepper? 5 out of 10. The rest of the possibilities. I have to grab one of them. There's no chance of getting anything else. All right, you sold the most for your school's fundraiser, so you get to enter the cash vault. So you're in the cash vault, and here's all the bills you can get. You can get a 1, a 5, a 10, or a 20. What's your chance of getting a $100 bill? Right, 0. There are no $100 bills in there. So the probability of getting a $1 bill is 48%. The probability of getting a $5 bill is 26%. And the probability of getting a $20 bill is 10%. After I say click pause, add all those numbers up and see if you can figure out the probability of picking a $10 bill. Hit pause now. Thanks, welcome back. So if I add all those up, I got a 48 plus a 26 plus a 10. What does that give me? I know you already figured this out. It gives me 84. So what's my chance of getting a $10 bill? My chance of getting a 1 is 48. A 5 is 26. So this is a $1 bill. This is a $5 bill. And my chance of getting a $20 bill is 10%, right? So what? Whoop, that's a 20. $20 bill is 10%. So my chance of getting a $10 bill is what's left. My chance of getting a $10 bill is 16%. Right? 84% chance of getting all the other dollars. 16% chance of getting a $10 bill. Let's keep rolling. All right, now we got 2 kinds of probability. Theoretical probability is based on knowing. Sorry, someone's calling me. I don't know why. Is knowing and calculating all of the equally likely outcomes. So that's like saying, well, if I did this a million times, what would happen? Like, what are all the chances? And this is what should happen. So theoretical probability is just saying what should happen. So it's the number, the probability of an event is the number of favorable outcomes over all the choices, the number of possible outcomes. Experimental probability is based on actual, so you're actually going to do the experiment and record what you get. And we're going to do some of that later on after this video. Actual repeated trials of an experiment, which just means you're actually conducting the experiment. And this is what actually happened. And think about it, you're making an experiment, right? It's what actually happened in the experiment. So this is the number that occurred. And it's over the number of trials. So the number of time you did it. Let's do an example. If you flip a coin, what's the theoretical probability? Theoretical probability you land on tails. Well, it's 1/2, right? My choices are heads or tails. If a coin is flipped 20 times, how often should you land on tails? Well, 10 out of 20, right? Half of my chances have to be tails. Experimental probability. This one's a little confusing, so listen carefully. Below are the results of choosing a card from a deck of cards, recording your answer, so you're writing down what you picked out, and then replacing the card. So here's my results. And it says, what's the probability of choosing? What they meant was, what's the probability, the experimental probability? Because they actually performed this experiment. Well, how many diamonds did I get? 10. How many cards are there in a deck? 52. So my experimental probability of choosing a diamond is 10 over 52. Theoretical, experimental. Let's have a little review quiz here. If I rolled a dice 30 times and it landed with a face up, with a 6 face up 10 times, is that theoretical or experimental? That's experimental. You're actually doing the experiment, right? I rolled a dice. 16 airheads in a bag, 4 cherry, 7 orange, 5 apple. The cherry ones are the best. The probability of picking a cherry is 1/4. That's theoretical, right? I actually have to perform the experiment to get experimental probability. Theoretical. We're going to go ahead and perform this together. Okay, and then afterwards, I'm going to go ahead and give you the answer to this. If you want to click pause and do 6, 7, and 8, go ahead. I'm about ready to give you the answers. Spoiler alert. Click pause. The probability of choosing a jack from a standard deck of cards, well, there's 4 jacks. How many cards are there? 52. What is the probability of rolling a composite number on a dice or a fair number cube? Composite numbers are what? They have multiples, right? So 3 out of 6. Those are the non-prime numbers. What is the probability of picking a vowel from the word mathematics? A, E, A, I. The probability is 4. There are 4 vowels out of 11 total letters. All right, guys, go to the back, grab some dice. You can do this experiment and then work on your homework and then a little IXL. Have a great night.